In this video, I'm about to do movable bridge mechanism, and you know, it's gonna be like each bridge, like from like each state and different cities in different states. Now this one is a first Strauss over here in Conway Train Bascule Bridge. And then I'm gonna show you the mechanism of how it was constructed. It was built in 1905 by the Strauss Bascule Bridge Company. Then I'm gonna show you, for us the wire arrow, how the moving parts, how they work, right? So now, first of all, now these are right here the Conway struts right here. Those are four corners of the Bascule Bridge, right? Of the first bridge. Now, this right here is a link between the Conway and the tower, right? Yeah, that's a tower right there, right? And and then you got the pins that that supports the end of the struts right there, right? And so it's real rooted to the span, and this the operator's machinery. I mean, operator's house or operated shanty right there, where the operator operate the bridge. And this one right here is the pinion carrier right there, right there. And those are the operator struts with rack on it. And I'm gonna show you when the bridge is lowered, right? So I'm gonna show you when the bridge is lowered, and I'm gonna show you how it works, right? See, the bridge is lowering, right? And you see when the bridge works, it is held in its original position, right? You see, look at the kind of weight it's going up, and look at the link to it and everything, right? So let me do this real quick so that way so I won't hear anything. Okay, you see the operator strut, it's going this way as the bridge lowers, right? And see the four joints of the Conway struts and the pinion, and then you got the machinery right there, and the shanty right there. Now I will show you when the bridge lowers. See, the bridge is lowered, right? See, the kind of weight is up, and look at the link, and then you got the four joints of the Conway struts that's connected, and then you got the pin right here, and then you got the operator strut right here with rack. It's like that, right? And when it when it raises, now the kind of weight comes back down, right? And the four joints goes down with it, and the operator strut with rack and the pinion carrier, it goes back all the way up to the top, right? See, it's back raised, you see? See the strut goes all the way up like that. And the link bends goes this way, and the counterweight is back lowered. And then you got the four corners of the struts right there that supports this bridge right here. You see, look at that. Look at the detail on this bridge, right? And I'm gonna show you the another angle of it. You see, this is a different angle of it. You see, that's the strut that connects right there. And then you got the pinion carrier, which is right there, right? And then you got the link right there. Look at all of that. All that's the link. And the counterweight and the four joints of the counterweight struts and the pinion right there. So that was removed in the late 1960s. And it will show you the other picture, the same picture. Boom, you see, look. And sometimes like when it's all 90 degrees, see the strut is all the way out. And then the link is like this. And the counterweight is lowered. And then look at the four joints of the counterweight struts, right? The pinion carrier right there. And then you got the pin that connects all four joints of the span of the first Strauss overhead counterweight train Bascule Bridge. Boom. And this is the where the strut is all the way up like that, just like that, right? And then you see right there, that's the operator right there that operates this bridge. And look at that. That's the counterweight struts of the four corners. Boom, boom. All right there. Yep, so now this bridge is located in Cleveland, Ohio. It was built in 1905, and then it was removed because of a shortcoming in late 1960s. Now this is the Chicago and Northwestern Railroad Strauss Bascule Bridge, which is the overhead counterweight train Bascule Bridge. Now this bridge right here, you see, you got the arm right here on both ends of the bridge that holds the counterweight right there, right? You see, that's the counterweight bridge chopper right here, right? And you got the part right here. It's like the the machinery right there. Now this right here is the strut. Yeah, that's a strut right there. And then you got the link right there. Counterweight. Understand? And the operator's house is on the right hand side. And I'm gonna show you when the bridge is lowered, right? Yep, that's located in Chicago, Illinois, crossing the North Branch Chicago River. Now the bridge, you see the bridge is lowering. You see the strut. When it lowers, you know, it goes like this on the opposite end. And this the arms right there. That's going down and like it's tilting over, but it's lowering. And you see, look at that, the kind of weight is going up, and look at the arm, right? Arm rest right there, the kind of weight, link, right? And then when it lowers, boom, you see, look, the links is like this in the kind of weight, and then look at that right there, right? Yep. Now you see the better view of this bridge. Now it's lowered. See the strut is at the end of this right there. Look, you got the Conway Bridge Tower. You got the arm right there, and you know this whole the concrete Conway right there, right? Got the pin right there that connects right there, and then also you got the pin that connects right there and whatnot, right? And see, look at that right there, a big chunk of steel right there that's holding the concrete conduit. And then when it raises, the conduit comes back down, you see, and the arm goes back down, the link goes back down, and the strut goes like this when it raises, right? Boom, you see, look. See the strut is going like that. The link is going down, the conduit is going down, and the arm's going down, right? Watch. See, it's raised, and the conduit is right there, and the link is right there. I'm gonna show you another picture of this. Bingo, you see, when I'm showing the white arrow, I'm showing you how the bridge works for us, the mechanism and the machinery on it, right? See, that's the arm right there, right? That's the rack that, and the pin that connects right there, both ends of the bridge. And then you got the machinery right there, and the operator's house on the right hand side of the bridge, the link. So, yeah, so that's what it is, right? So I told you I'm showing you different bridges. I ain't gonna show them in the same city though, but I'm gonna show different bridges like in like each state and different cities. So especially the ones that is unique ones. So so on the road, y'all. Now the next bridge is the JM Draw. Now this is a Strauss Hill Train Bascule Bridge early design. Now you see right here, it's the framework right here, the truss framework right here. You got the counterweight, you know, that's got the steel shape sheet plate around it, understand? Conway Bridge Tower, right? And then you got the strut with rack that's connected to the Conway Bridge Tower. And this right here is the operating machinery that mounts on the Bascule span. And this the link with railings with the stairs on it, right? And it's raised, right? Let me show you when the bridge lowers. And then I'm gonna show you how the mechanism works. You see, as the bridge lowers, the kind of way it goes up with the framework, and the link goes down, and the strut goes down as the bridge goes down, right? And the machinery right there on the Bascule spin goes down with it. And then when it lowers, boom, you see, look. The counterweight, framework, operating links right there, operating machinery right there. And then you got the pinion carrier right there that's on the end of the Bascule spin right there, right? Just like that. And then the strut is like this. That's connected to the conduit bridge tower. And then when it raises, understand? When it raises, the conduit goes back under the conduit bridge tower, right? With the framework, right? Hold up. You know what I'm saying? Here we go. And let me show you something. Here we go. So sometimes it don't want to act right. Here we go. Now you got the conduit goes down under the conduit bridge tower, and then you got the strut goes up like that, and then you got the machinery on the Bascule spin right there, and then you got the link folds to the framework. Now it's raised, you see. The strut is like this. It's up. You know, it's like in the center span. Now that's the pinion carrier that's right there, right? The pin that connects right there to the conduit bridge tower, right? And then you got another pin that connects right there, pin right there. Counterweight. You got the truss framework right here, right? And then you got the link with the railings and with the stairs on it. Now this bridge is located in Ashtabula, Ohio. Now go to the next bridge. Now the former Michigan Central Railroad Strauss Hill Train Bascule Bridge. Now this is a later design. You see that the strut is fixed to the conduit. Now actually the strut is fixed to the Bascule spin, right? And the machinery is mounted on the conduit bridge tower, framework, link, and two-wing conduit, right? And then when the bridge lowers, now you see when it lowers, you see right there, the conduit goes up with the framework, the link goes down like that, and operated machinery right there, and then you got the pinion carrier that's right there, right? It's right there, right on the near the machinery right there, right? Boom, it's lowered. You see, look at that, it's lowered, right? Pinion carrier right there, operating machinery right there, towing convoy right there, and the strut is fixed to the Bascule span, right? And then when it raises again, back for bolts, you see, convoy comes back down, right? And with the framework and the link, and operator strut goes like that through the pinion carrier right there. And it's raised, you see, look, boom, pinion carrier right there, strut, fixed to the Bascule span, machinery, Bascule convoy bridge top with a 2-wing convoy. So, yeah, so this is a later design. It's built in 1923 in Detroit, Michigan. Now, this is the first Bascule Bridge in Detroit, Michigan. Now you see, this the counterweight, this is the box counterweight. This is the incline track with rack. And then you got the truck with the machinery right there, right? And then you got the A-frame tower right there, right? And then you got the pins that connects right there. And then you got the rocker arms right there that connects right there. Got the rocker arm right there. And then you got the struts right there. And then you got the framework right on top of the top. Now, when it lowers, I'm gonna show you when it lowers and how the mechanism works. You see, when it lowers, you know, it goes like this. The box convoy goes up, the link goes up, the rocker arm goes like that, right? Then it connects right there to the truck with the machinery on it, right? And then when it lowers, boom, like that, right? You see, look, it lowers. You see, the rocker arm right there, struts. You got the truck with the machinery on it. You know, with the wheels. I see you got the wheels on each side, right? And then you got the framework, which is connected to the box convoy, right? You see, look. Now when it when it raises, it goes back in and it rolls back down the track or the incline track rack with the machinery, with the truck, with the machinery on top of it, right? The link goes as the bridge raises, as the rocker arm goes like that, and then after it raises, it goes like this, right? Goes like that, right? And now the bridge is raised, and look at the, yep, it's right there. The convoy with the framework hangs like a program, right? And look at all of that. the rocker arm and everything goes like that, right? It's still in use. Yep, it's in Detroit, Michigan. Back to Ohio. Now this is the 1956 Hill Trunnion Bascule Bridge, which is the BNO 463. Now, the machinery mounts right here. You see, without the white area is that. That's the machinery right there. The operating strut that's that is connected right here to the portal span, counterweight, framework, link with the lowers. You see the strut. See the Bascule span right here pulls the strut right straight, right? Got the pin carrier right there, right? Conway right there, link. Link right here, framework, right? Boom. See, it's lowered. You see? At the end of the pin carrier right there, it's like this, right? Pin carrier, counterweight, box counterweight, framework, link. When it raises, it pushes the strut straight ahead. The counterweight comes down with the framework and the link folds against the framework. Boom, it's raised, you see? Right there. Right there. Pin carrier right there. And it pushes it like that. Goes just like that. All right, so it's a Cleveland, Ohio. It's abandoned. Now this bridge is a Scherzer rolling lift bridge. Now this bridge right here was designed by Albert Scherzer, William Scherzer's brother. Now this is the rollers right there, which is the conduit and the conduit track, counterweight, pinion right there, machinery right there, beam, that's the beam with the rack, beam with rack, and it rolls back and forth like a rocket chair. I'll show you. You see it's lower and it rolls to the closed position, right? You see, look at that. Look at that right there. Here we go. Look at that. You see, it rolls, right? And look at the conduit goes up, and the pinion goes. When it lowers, I'm gonna show you. The pinion ends right there. Ends right there, right? Counterweight, conduit rollers, you know, with teeth that matches with the with the holes in them, understand? So that's all roller lift bridges, all Scherzer type roller lift bridges that has conduit and the rollers that mash with the hole, and all of that stuff. So mash with the teeth and all that stuff. So rolls back, you see, it goes like that, and the pin goes like that when it raises, right? Now it is raised, right? Yep, next bridge. Now this is a railroad vertical lift bridge, right? It's located in Oakland, California. Now, this is a tower span vertical lift bridge, which is it's a Baltimore Woman through Truss. And then you got both ends of the lift span. You got the machinery on both ends of the lift span, right? And this particular bridge has balance chains. Now you see you got the balance chains right here on each side of the bridge. One right there, and then you got right there balance chains right there. Then you got the ropes, kind of way ropes and sheaves. Understand that supports the counterweight and everything, right? When it raises, it's like this. The balance chains like that, but when it lowers, the balance chains is like this. It's like that. It connects like from the counterweight to the end of the tower, truss tower, right? On both ends of the bridge, right? See, balance chains right there. Yeah, so yeah, balance chains right there, right there, and right there, right? So there you go. Next vertical lift bridge. Now this is a span drive vertical lift bridge in Napa, California, right? Meaning that the machinery is on top of the lift span, right? And then you got the ropes right there that support it. Sheaves right there. And then you got the sheaves right there on both ends on two towers. Ropes, cutaway ropes right there, right? On both sides of the bridge, right? Right there. So when it raises, it's like the cutaway goes down, but when it lowers, the bridge goes down and the cutaway goes up, right? So that's where it's at, right? Yep. I'm just gonna show you two examples of these vertical lift bridges. Now I'm gonna show you some swing bridges. Now this is a railroad swing bridge, long bridge in Washington, D.C. Now this bridge right here is a center bearing, you know, and and it's got rollers to but it's in the center, right? And it swings aside for boat traffic and it swings back for train service, right? So now that's used by the CSX Railroad, right? And let me show you another bridge that is a rim bearing. Now this is a Center Street Bob Till swing bridge with the rim bearing with the tapers around it and everything, right? So it swung. See, like when this swings, it swings aside for boats See, look at this right there. Now they had replaced the rim bearing though, but I'm gonna show you when the bridge is closed. Boom. Now this is bridge when it's closed for highway traffic. See, this is a rim bearing swing bridge right there. Yeah, all the mechanism in it. Now these are the examples of the movable bridges, the how they work for us, the mechanism on these bridges. Bascule bridges, vertical lift bridges, and swing bridges. So